Hi everyone, I wanted to go over a little bit of the normal probability distribution. The normal distribution is the bell-shaped curve, and here we can see in a lot of problems it will tell you, it'll say something is normally distributed. So in this problem we can see the words normally distributed right there, which tells you that it's a bell-shaped curve. This problem has to do with reading rates for sixth graders, normally distributed, bell-shaped, with a mean 135, so that's right down the middle, and a standard deviation of 25 words per minute. So if I were to draw a picture of a bell-shaped curve, it would look something like this. First, I would start off by making like a horizontal line, like an x-axis. Then I will draw something that looks sort of speed bump-like that. Then I will, right down the middle, write the mean. Now it says the mean was 135, so right down the middle is 135. And then about these points right here, called inflection points in calculus, that's one standard deviation higher, so that would be 25 plus 135, which is 160. And this value over here would be 25 subtracted from 135, which is 110. So there's what the bell-shaped curve looks like. Okay, now we're going to use the same bell-shaped curve on all of the parts A, B, C, and D. So I'm going to take a moment and copy that. Okay, so now in order to find the probability in the first statement, the probability that a student has a reading rate less than 100, that is to say the probability that a student's reading rate is less than 100, I'm going to use the app that we use in class. So I'm going to open that up. I have to remember that the mean is 135 and the standard deviation is 25, and plug those into the app. So right here where it has the mean, I type in 135 and the standard deviation is 25. And in this case, we wanted less than 100 words per minute. This is already set to less than, and there's the picture. It tells us that the area that's pink, the shaded pink part, is 0.08075. So I'm going to call it 0.0808. So that would be equal to 0.0808. There's 100, and we found this piece right there, the area that was on the left. Okay, now to find the probability that a student has a reading rate higher than 200, well, 200 is way over here someplace, and higher than 200 means this little tiny smidgen right there. So it's a very small area, it appears. So to find that out, I will write this first of all in proper statements. The probability that a reading rate x is more than 200, higher than 200, equals, and I'm going to use the app to get the area. So change the 100 to 200, and change this to greater than, because we want higher than. And it tells us that's this little tiny sliver of pink way off to the right, just beyond 200. And the area is the probability, which is 0.004661, or 0.0047, we'll call it. So that's 0.0047. Okay, now the third problem, part C, is related to the first two. It says, find the probability that a student has a reading rate between 100 and 200. So 100 was down here someplace, lower than 110. 200 was way off to the right. And what we're looking for is this probability in between. So the best way to get the probability that's between two things is to think about the total for the whole thing. This whole thing here is 100% in decimal form, that's just 1. Now we know that lower than 100 is 0.0808, and above 200 is 0.0047. So if we subtract those two pieces from 1, what we're left with is what's in the middle. So the probability that x is between 100 and 200 is 1 minus 0.0808 minus 0.0047, which is equal to 0.9145. Okay, so for the last problem, we're trying to find the quartiles for 6th grade reading rates. You remember the quartiles divide the data up into groups of 25% each. So I'm just guessing, if I put a line right down through the mean, that's going to be Q2, 135, because that splits 50%, it will be lower, and 50% will be higher, right? Okay, so then we have to find the first and the third quartiles. Those ones are going to be the hard ones. I'm just going to make a supposition, a little guess right here, that the first quartile will be somewhere around right there, and the third quartile will be somewhere around right there. There's Q3. Now, if we've done it right, we should have 3 groups where that's 25%, that's 25%, that's 25%, and that's 25%. Okay, so then the probability that x is less than whatever the first quartile is should be 0.25. So if I use the app for that, I'm going to change the probability to 0.25 and make it less than, and it gives me the x value. That x value, 118.1, we'll call it 118.1, that's the first quartile. So Q1 is equal to 118.1. 118.1. Now to get the third quartile, we could say the probability that x is greater than Q3 is also 0.25, or we could say the probability that x is less than Q3 equals 0.75. Either way, we'll get the same number. So let's see. Greater than, we want that to be 0.25. 0.25. So we type in greater than 0.25 is the area on the right, and we get 151.86, or 151.9. So that would be 151.9. And those would be the quartiles. Q1, 118.1. Q2 is the mean, or the median, and Q3 is 151.9. Okay, I hope that helps. Thanks very much. Bye.